Hello friend, today we are going to discuss the AC voltage and current systems with a guiding question saying as follows. Explain the following terms as applied to AC circuits. 1. Waveform, cycle, period, peak factor, average value. Part B. An alternating current is given by the following equation. I equal to 150 sine 120 pi t. Determine its maximum value, that is Roman 1 of that question. Find the period, a frequency, instantaneous value when t is equal to 2 milliseconds, and the root mean square value of this particular AC voltage. When you look at the solutions, let us first consider a sinusoidal waveform. By the way, a waveform is the shape of the curve obtained by plotting instantaneous values of alternating quantity, which could be current or voltage, along the y-axis, and time or angle along the x-axis. So if we plot the values of voltage, for example, against time, we know at a maximum in the first half cycle, we shall have the maximum, and in the next half cycle we have the minimum. So this maximum value is equivalent to the amplitude of that AC kind of system or sinusoidal waveform. So V naught, which is the maximum voltage, is the amplitude, and the time taken to complete one cycle. This is one complete half cycle, another one. We get a period, that is the time taken to complete one oscillation or one complete cycle. Then a cycle is the number of actually cycle is one complete set of positive and negative values, or just one complete revolution. If we are to define period, as we have already indicated, we shall say that period is the time taken by alternating quantity of voltage to complete one cycle, and is denoted always by capital T and measured in seconds. We know that T is equal to the reciprocal of frequency, and it is in seconds. If frequency is equal to omega out of 2 pi, whereby this is the angular frequency divided by 2 pi radians, then it means, substituting in this formula, the period time T will equal to 2 pi divided by the angular frequency omega, and giving you period in seconds. What about the peak factor, or what we call a crest factor? Is the ratio of the maximum value to the root mean square value of an alternating quantity, which can be voltage or current. Therefore, if the crest factor is K, it is equal to I naught, which is the maximum value, divided by root mean square value. The maximum value is denoted by I naught, for example, for current, and therefore root mean square value is I naught, which is the maximum value, divided by root 2, and this will give you 1.414, and that will be the crest factor for this alternating voltage with a sinusoidal form. Part V, or part 5 of this question. Average value of an AC is therefore that value of DC which would send the same amount of charge through a circuit for half cycle of AC through the same circuit in the same time, and it is denoted by if it is current, then average value of current will be 0.637 times the maximum value. Likewise, if it was the voltage, then maybe we could have something like this, AV, which is the average value of voltage, equaling to 0.637 V naught. But for that matter, since it is not required, we can also. So to answer the next question, which is part B, an alternating current system is given by the function I equal to I naught sine omega t plus phi, whereby I naught is the maximum value, the peak value, omega is the angular frequency, whereby omega is equal to 2 pi f, and phi is the phase angle. Hence the equation becomes I equal to I naught sine 2 pi f t plus phi. Then it means, according to the given equation, which is I equal to 150 sine 120 pi t, if we compare the two equations, we therefore find that I naught sine 2 pi ft plus phi is equal to 150 sine of 120 pi t plus 0. Here the phi angle is 0 when we compare the two equations. Therefore, the maximum value I naught will be 150 amps, and the frequency will be determined from this formula. 2 pi f is equal to 120 pi. So we will find that the frequency is equal to 60 Hz. What about period? Period is equal to the reciprocal frequency and is equal to 1 out of 60, which gives you 16.7 milliseconds. Instantaneous value, or value at any time t. So given by the function, by the current, which is the function of time t, at t equal to 2 milliseconds, and this is the same as 2 times 10 to the power negative 3 seconds. When we substitute, it becomes I over 2, or at 2 milliseconds will be 150 into sine 120 pi times 2 exponent negative 3, and this will give you 102.68 amps. Remember to convert this value to radians so that you avoid errors. What about the root mean square value of this AC voltage? The root mean square value is given by the maximum value of that AC quantity divided by the root of 2. And this is equal to 0.7071 I naught. So when we substitute in the I naught, which is the maximum value, we get the current as 106.07 amps. Thank you so much. See you in the next video.